Well, thank you all very much for coming here. My name is Richard Peto. I shall be chairing this, and this is a student society debate. And here we have Roy and Nessa, who are going to explain about the student society, the debate, life, the universe, and everything.
I don't know if this, okay, good, this is on. So we're not really going to talk about life and the universe, but the rest of it, we will talk about it. So again, good evening, everyone, and welcome to the debate of the ages, organized by the Oxford University Scientific Society.
I'm Nessa.
And I'm Roy.
We represent the Oxford University Scientific Society, which is the oldest scientific society in the world.
Our society's main goal is the public dissemination of scientific information.
But our society belongs to the City of Oxford, not just the university. So events like this are open to everyone and designed to engage everybody.
In order to fund these scientific public engagement events, we depend on your generosity. So please donate to our society, your society, at the end of this debate.
The proposed motion tonight is this House wants to defeat ageing entirely.
Our initial analysis of the registration database shows that 25% of you support this motion and therefore side with Dr. Aubrey de Grey. 35% of you oppose this motion and therefore side with Professor Colin Blakemore, and 40% of you are neutral.
Tonight's debate is being chaired by Professor Sir Richard Peto. He is Professor of Medical Statistics and Epidemiology at the University of Oxford and Director of the Clinical Trial Service Unit. His work has included studies of the causes of cancer, particularly the effects of smoking, and the establishment of large-scale randomized trials. He was elected a Fellow of the Royal Society in 1989 and was knighted in 1999 for services to epidemiology and to cancer prevention.
So finally, before we begin with the exciting night of science, I'm going to give you just a short description of the debate program. So the first 5 to 10 minutes, Professor Sir Richard Peto will introduce the topic at hand, and he will also introduce Professor Colin Blakemore and Dr. Aubrey de Grey. Then, for the next 15 minutes, Dr. Aubrey de Grey will speak for the motion, followed by Professor Colin Blakemore speaking for 15 minutes against the motion. This will be followed with a 15-minute Q&A session directed by Sir Richard. At the end of that, there's a 30-minute session where all of you can ask any question you want directed at Professor Colin Blakemore or Dr. Aubrey de Grey. At the end of that 30-minute session, there'll be a 5-minute riposte and summary by both Aubrey de Grey and then Professor Colin Blakemore. At the end of that, there'll be just 5-minute closing remarks by Sir Richard, and that'll be the end.
May I now welcome Sir Richard to commence the debate.
Well, first, if you've got a mobile phone, then turn it off. Otherwise, you will not do any more aging. Basically, it's a very odd thing that people age in the way they do. And there's all sorts of ways that evolution could have avoided it happening. You know, women become a bit less fertile in their 40s and then have the menopause. Well, it would be easy to have a few mutations that made that not happen. Then they'd go on having more kids, and that would be selected for. So why doesn't it happen? You know, having taken all the trouble to make a body, why let the thing age? I mean, it's almost as though evolution seems to have chosen this strategy of, first make them young and then kill them off. And the extent to which this happens is quite extraordinary. If you take a lot of types of cancer, then if you compare 20-year-olds with 80-year-olds and say, what's the chances you're going to get cancer tomorrow? Then it's about 1,000 times big in an 80-year-old. Well, why? I mean, it seems very odd, and many other diseases as well are vastly more common, or at least the degenerative diseases, if you like, the non-communicable diseases. They're vastly more common in the old than in the young. Why? And it's odd. And 60 years ago, there were papers written by Richard Doll, among others, on multi-stage models, which pointed out that if you if actually the cellular processes that culminate in cancer are nothing to do with age, then if they just happen at the same rate in old cells and in young cells, you could still finish up with cancer being 1,000 times more common in the old than in the young. Because, if, say, compare an 80-year-old with a 20-year-old, then each of those changes has had 4 times as long to happen. And if there's, say, half a dozen such changes, well, 4 to the power 6 gets you up to something like 1,000. So it could be that you just need several changes to fall to bits, and just if you're twice as old, you've had twice as long to have them. If you're 4 times as old, you have 4 times as long to have them. So you can get disease being much commoner in old age with nothing that you should really call aging underlying this. And, experiments have been done with animals where you start exposing them to carcinogens at different ages, and there doesn't seem to be any particular greater susceptibility among the old than among the young. And if you smoke from 20 till 40, and then you say, what's your chances of getting lung cancer at 41? Or if you smoke from 40 to 60, and you say, what's your extra chance of getting lung cancer at 61? They're not very different. So you can get things where the disease depends strongly on duration of exposure. And of course, generally, old people have had a longer duration of exposure. So it doesn't have to be anything called aging. And yet that's a somehow unsatisfactory explanation. Cancer rates go up steeply with time in mice. They go up steeply with time in men. And after about 2.5 years, mice have got a few % chance of getting a cancer. Well, every little bit of me that was the size of a mouse had got a few % chance of having a cancer in 2.5 years. I'd be riddled with cancer by the time I was 2.5. And by the time I've got to be, 68, 69 next month, actually, then, I'd probably have about 1 million or 1 billion cancers would have arisen. And so, how has evolution achieved this? How does it get human cells to actually do this so much more slowly than animal cells? There's something there awaiting discovery. And it's being investigated. And I think the investigations vary from Aubrey, who is extremely optimistic that we're actually quite close to it, and who believes that the first person to live to 1,000 has already been born. In fact, I think Colin calculated that the first person to live to 1,000 must already be 68. Because you said something like 8 years ago that they were already 60. And Colin is absolutely certain that Colin is not the person who's going to live to indefinite old age. And so let us hear their reasons. Aubrey de Grey. Aubrey is the director of, now, I've got to get this right. Now, you can introduce your institute itself. It's for engineered negligible senescence. So studying how to get engineered negligible senescence, trying to change things, and Colin's just trying to study things the way they are here in Oxford. So go ahead. Aubrey de Grey.
Well, thank you very much, Richard, for that excellent introduction, and thank you all for coming. I am delighted that so many people have found this topic to be so interesting as to take time out of their evening. But, of course, I only have now 15 minutes to make the case that we ought to defeat aging entirely, which is a pretty challenging time limit, so I'm going to dive straight in. I'm going to start by highlighting and analysing, one at a time, 3 individual words in the motion. First of all, aging, then once, and then entirely. Starting with aging. So Richard has just given an interesting and very eloquent description of why it may actually be doubtful that there actually is anything called aging. However, I would say that this is in some sense a matter of terminology. It seems to me that the accumulation of progressive molecular and cellular changes to the composition of the body as side effects of the body's normal operation can be described as aging, and indeed is appropriately described that way. Whereas the phenomenon that Richard was explaining may, at least in some cases, not actually occur, is more of whether there is a positive feedback loop in aging. In other words, whether aging speeds up as it progresses. Now, I think that in some areas of aging, there is evidence for such positive feedback. In others, that evidence may be more fragile. So I think that's an interesting area of research. But I'm going to take the broader definition of aging as simply the lifelong accumulation of these side effects of the normal operation of the human body. that eventually contribute to age-related diseases and disabilities by virtue of the fact that the body is only set up to tolerate a certain quantity of that progressive change, I'm going to call that change damage, and not an indefinite amount of that change. Now, this definition of aging as the lifelong eventual cause of age-related ill health brings me to a point that I'm going to come back to repeatedly over the next 15 minutes, namely that actually the whole topic of attempting to defeat aging with medicine is all about health. It's not about longevity. It's not about longevity. Benefits that might occur as a result of the successful intervention in aging in terms of the extension of longevity would be side benefits. And really, this is a way of highlighting the fact that the idea of intervening in aging as a medical goal is no different, really, from any other medical goal, except in degree. So far, medicine has had a number of good successes, which have had only a modest impact in how long people live. Certainly today, when we are trying to push back the diseases of old age, the impact has been very modest so far. And it may be that if we can completely defeat aging, the impact on longevity would be much bigger. But it's still simply what medicine is all about. It's extending health and thereby, as a side effect, extending longevity. So that's a very important point, I think, that everyone needs to grasp. So now, let me get on to the word wants. Now, the Scientific Society would not come here to debate a motion that said, this house wants to develop perpetual motion machines. And the reason it wouldn't is because it's not coherent to actually want something unless there is some reason to believe that one could achieve it. One might not know that one could achieve it, but one thinks that it's actually a plausible goal. So even though the motion is ostensibly focused on the desirability of defeating aging, it does incorporate also the feasibility. And I think that all of you here, especially since this is a scientific society, will be interested in knowing more about that. So I'm going to spend a few moments on that. The thing about the feasibility of defeating aging is that it changes with the advent of new technologies. Many people would have said, at least 10 years ago anyway, and certainly longer ago, that defeating aging, or even substantially postponing aging, age-related ill health, by, let's say, a few decades, was highly implausible. But, supposing that you were speaking in 1900 about the feasibility of crossing the Atlantic in less than a day, and the idea that one might be able to do that only 30 years hence, people would have said that was preposterous if they had made the mistake of extrapolating from the rate of progress of speed of ocean-going liners. It just so happened that completely different technology became applicable to that question, that challenge, and sure enough, made it possible to traverse the Atlantic in a very much less time than previously. The analog today for aging comes down to two words: regenerative medicine. Regenerative medicine is all about restoring the function of the body by restoring its structure to how it was before it had suffered some kind of damage. And we mainly think of regenerative medicine as focused on acute injury like spinal cord trauma or whatever, but it can certainly, in principle, be equally applied to the gradual accumulating damage that we see in aging. And regenerative medicine has made immense, breathtaking strides over the past decade. That is what led me a decade or so ago to realize that we might actually be within striking distance of bringing aging under genuine medical control, the same sort of medical control that we have today in relation to most infectious diseases. Now, that was a bit of a hard sell early on because regenerative medicine researchers and aging researchers didn't talk to each other very much back then, but now it's not like that anymore. It's no accident that the foundation that's been created around my work has a scientific advisory board of 20-odd extremely prestigious researchers who are willing to associate themselves with the concept that regenerative medicine has a fighting chance against aging. It's no accident that I regularly now get asked to organise entire sessions at mainstream gerontology meetings, when 5 years ago I'd never even been asked to give a talk at such a meeting, despite my reasonably high profile in the wider world. This is no longer a preposterous, radical, heretical idea. This is an idea which those in the field have been exposed to in enough detail to know that it is actually something that needs to be taken seriously as a plausible alternative. So now I'm going to move on to the third word, the word entirely. A lot of people misunderstand this when they see abbreviated accounts of what I say and what I've written. People seem to think that I am saying that within the next few decades, we have a very good chance, let's say a 50-50 chance, of developing medicine that can actually completely repair all of the various types of molecular and cellular damage that constitute human aging, and thereby extend longevity indefinitely by periodic application of that repair. Some people, who are even more callous, say that I think we can cure aging. In other words, actually develop a one-off treatment that would make people non-aging. And I certainly don't say that and never have. I also, however, have never said that we can develop perfect regenerative medicine against aging in the foreseeable future. However, what I do think is very likely is that within the next few decades, we will generate regenerative medicine that can buy us a few decades of time. In other words, can take people who are already in middle age, let's say 60, and fix them up well enough that they won't be biologically 60 again until they're chronologically 90. The time that we buy then will be used to improve the comprehensiveness of those therapies so that we can re-rejuvenate people one more time and one more time. And I believe that we will have a very good chance of staying one step ahead of the problem indefinitely, so that longevity can be increased indefinitely as, again, a side effect of postponing ill health of aging indefinitely. This is an incremental approach, but it's an approach that has the same fundamental outcome as a complete elimination of aging starting from square one. So that is why I talk about the entire defeat of aging. And furthermore, that is why this is so much more plausible than it would be if we were talking only about slowing aging down, rather than about genuine repair, genuine preventative maintenance. We have to understand that this is fundamentally preventative maintenance. It's preventative geriatrics, preventative medicine for the diseases and disabilities of old age. Ultimately, there's a big, obvious reason why geriatric medicine is so ineffective, why the diseases of old age have been so refractory to medical intervention. It's because they are caused by something that's accumulating, by these initially harmless molecular and cellular changes. And therefore, it's a losing battle. It's a downward spiral. We cannot expect to have much success treating the diseases of old age in the way that we would treat a standard infectious disease. All right, so that's set the stage. Now I want to say something about responsibility. A number of scientists have accused me of irresponsibility in talking about the prospective longevity benefits that might accrue from applying regenerative medicine to the problems of aging, because they feel that these predictions are preposterous, and therefore that they are distracting, inappropriately, attention of the public and of policymakers and funders and so on from the serious business of getting on and actually addressing the diseases of old age that are so prevalent in today's society. But hang on, who is actually the irresponsible one? That rather depends on the science, doesn't it? Because if I were right about the plausibility and indeed the promise of developing medicines against the diseases of old age that really work, that push back those diseases of old age and all the disabilities of old age by much more than any other approach has any chance of doing anytime soon, then surely it is the critics of this approach who are being irresponsible in over-hasty dismissal and ridicule of these ideas. And I had exactly this sort of battle in the gerontology community maybe 6 or 8 years ago in the US, and I'm very pleased to say, as I mentioned a few minutes ago, that that battle has essentially been won, and this approach is now taken seriously. I'm delighted that I now have the opportunity to discuss all of this in the UK in a similar manner, and of course I'm hoping that the outcome will be similar. But that leads us now to the essence of this debate, the desirability question. Because, of course, it's fine, in some sense, to dismiss a radical technological proposal, even if one's scientific reasons for doing so are completely inadmissible, if the result of success in implementing that technological proposal would be undesirable. If we actually don't want to cure aging, to defeat aging, then let's just ridicule the idea of doing so. Makes sense. So, let's think about that. I've pointed out now a couple of times that this is all about health. Now think about that for a moment. If you oppose this motion, in other words, if you're thinking that you don't want to defeat aging entirely, then you must be holding one of two positions. Either there is some age at which you think it is good for people to get sick, or there is some age at which you think it is good for people to die even if they're perfectly healthy. Think about that. Now, which of those positions does anyone in the audience hold who actually thinks they're against the motion? Think about that before Q&A. Because the fact is, they both sound pretty ageist, don't they? They don't sound like the modern ideal of treating old people as if they were people too. I mean, I've never run the Samaritans, but I'm fairly sure that when you do so, the first thing they ask you is not your date of birth so that they can put the phone down if you're over 85. The fact is, we do regard old people as people too, and the only reason that we regard medicine for old people in a different way than medicine for young people today is because of the practicalities, the fact that we don't have good medicine for old people today. That is not an argument for not developing that medicine. Now, of course, one could try and finesse this. One could try and get out of it by saying, well, okay, what does it actually mean to be sick? There are some people who are 90 and they're pretty healthy. But are they? Maybe they don't have the diseases of old age, the specific ones like Alzheimer's and cancer and cardiovascular disease. But can they keep up with their granddaughters on the dance floor? I don't think so. The fact is, being healthy is not just about not having the things that medics give names to. It's about all of the aspects of decline of function that go with having been born a long time ago. So finally, let's stand back from all this and say, well, what is left for people who oppose this motion? There's only really one opportunity, is to take it head on and say, okay, historically, medicine has been good for everybody. Historically, yes, 150 years ago when we discovered that hygiene was a good idea and was going to save a lot of infant lives, we did not take the view that we should actually conceal this information until everybody had agreed to use contraception, right? And we think it's good that we didn't conceal the information. We think it's good that we got that out there. But maybe in the future, the impact of this particular advance in medicine that we're talking about might be so ghastly that maybe medicine isn't such an unalloyed good thing after all. So let's look at that question in detail. And the thing that I want to say about it is to focus on uncertainty. Many people, when I talk about this question, they say, oh dear, won't we have too many people? Won't we have a dramatic decline in the death rate, people carrying on being born, far too many people, massive environmental problems, don't want to go there. Maybe we will, but maybe we won't. We know nothing about what the birth rate is going to be 100 years from now or 50 years from now. We know nothing about what age the average woman is going to have their children, which of course has an enormous impact on the trajectory of global population. We know nothing at all about other technologies that may reduce our carbon footprint and thereby increase the carrying capacity of the planet, thereby eliminating the problem in another way. And the fact that we know nothing about these things is all we need to focus on in acknowledging that we have a clear and present moral obligation today to develop these technologies. Some people talk about the precautionary principle. They say, let's not develop technologies that would be bad. But here's the precautionary principle in relation to the defeat of aging. The scenario that we should be avoiding is a scenario in which humanity of the future looks back and blames us for not developing medicines against aging and thereby for condemning them to an unnecessarily miserable old age and an unnecessarily early death just because we thought we were so clever about how the world was going to be and we thought that it was actually doing them a favor not to develop these medicines. That's the position I don't want to be in. I do not want to be blamed by our descendants, and I don't think you do either. Thank you very much.
Okay, thank you, Dr. Aubrey de Grey. What I should have said, incidentally, is that at the end of all this, when we come to it, it's certainly not possible to get us out through one lot of doors saying ayes and another lot of doors saying noes, and then the abstainers go that way. And so I'm going to ask for a show of hands, and I shall be the one who judges what percentage say aye and what percentage say no. I might even ask for abstainers as well. But that's going to be the procedure at the end, and whatever percentage I say it is what it is. Now, in your talk, you said that part of the question is this actually going to be practicable, that this is an implicit thing? We're not trying to debate whether or not this House would like perpetual motion machines. And as I understand it, this is one of the subjects which Professor Blakemore is going to speak on. So, Professor Colin Blakemore.
Thanks, Richard. Thank you, Aubrey, for your introduction. Thank you for coming to this meeting. I'm delighted to have this opportunity to speak to this group. I have to make a confession. Unlike Aubrey, I'm not an expert in the field of aging, though like Aubrey, I do have views beyond my expertise. In Hans Christian Andersen's fairy tale, the little mermaid wins not just a pair of legs, but the chance of eternal life if she can secure a human soul. What the sanitized Disney version doesn't tell you is that the other half of the deal was losing her tongue and suffering perpetual pain. What Aubrey de Grey is offering you is eternal life without the pain. This is snake oil, and dangerous snake oil. There are two main reasons why you should reject the idea of defeating aging completely. First, the mission is utterly unrealistic and is a distraction from the hard and costly task of preventing and curing disease, whatever the age at which the disease happens. Secondly, if this miracle should somehow happen, the consequences would be a disaster for humanity and for the planet. Let's be clear about what Aubrey's agenda is, what gets him headlines and what raises money for his foundation. It is immortality. In a lecture in Oxford last September, he said, "I don't work on longevity, I work on health," and that's what he said, of course, this evening. But he established, wait for it, the Methuselah Foundation, which offers enormous prizes for researchers who extend the lifespan of mice. Why is the image on the annual report of his current Sense Foundation a photograph of a NASA rocket? Could it have something to do with his prediction that within 25 years we'll reach what he calls longevity escape velocity, when the gain in life expectancy is more than 1 year for each year of research? As early as 2004, he wrote a piece for the BBC News Channel website entitled, "We Will Be Able to Live to 1,000. In that article, he said, "I think the first person to live to 1,000 might be 60 already," and as Richard said, that was in 2004, so that lucky person's 68 now, Aubrey, and still waiting. In 2009, in the BBC programme It's Only a Theory, he argued that the first 1,000-year-old human had already been born. And last month, in Lunt's World blog, he was quoted as saying, "Given sufficient funding, we shall have a 50-50 chance of completely stopping people from dying of old age within about 25 or 30 years from now." Just on the basis of what he says then, very publicly, I think that it would be reasonable to conclude that Aubrey would interpret defeating aging completely to mean a massive extension of life expectancy. Okay, maybe part of this bias in presentation is a problem of the media. Maybe they're not as interested in osteoporosis, congestive obstructive pulmonary disease, or bunions as they are in eternal life. But you'll notice that none of the quotes or headlines says anything about the incredible range of age-related diseases and disorders that would have to be solved if Aubrey's promise to abolish aging were to be fulfilled. You've heard a different story from Aubrey tonight. You'd think that the Sense Foundation is focused entirely on research aimed simply at understanding and treating age-related disease. But look at what he wrote in this year's annual report. Recently, a number of people have told me that my message has changed. They are surprised that I might object to a headline discussing 1,000-year-old lifespans. They believe that I've toned down my approach to discussing Sense Foundation's research and its implications. I can see why people think this. It's true that the things that I'm now saying are different from the things that I've been saying in the past. But it isn't my message that's different, or sense foundations for that matter, but rather the topics that we're discussing. So Aubrey might have been persuaded by publicity to change what he says, but he hasn't changed his views. I think we need to reflect a little on exactly what we mean by aging, and you've heard some of the difficulty of that already, and where that apocryphal 1,000 years or so might have come from. Clearly, old animals are different in various ways from young ones. More wrinkly, less mobile, less strength, less stamina, less likely to reproduce. But for our purposes, aging is better defined in terms of a propensity to disease and to death. Older animals tend more easily to get ill and more commonly to die. The total death rate from all causes is 500 times greater at age 80 than at age 20 in this country. And indeed, 80-year-olds are 1,000 times more likely to die from common cancers other than those related to changes in sex hormones. The common sense interpretation is that some inevitable gradual degradation of cellular processes, let's call it aging, must underlie this increasing tendency to illness. But as you've heard from Richard, together with Richard Doll, he explained that although old mice tend more frequently to get cancer than young mice, dramatically so, their total lifespan is only 2.5 years compared with humans, and they calculated that a gram of tissue in a mouse is at any age 1 trillion times more likely to develop cancer than a gram of tissue in a human being of the same age. So if a tendency to disease is what people mean by aging, it certainly isn't a process that's shared by all cells with similar genomes. It must somehow be regulated by factors that can be inherited differently in different species. Well, some have argued that aging is actively genetically programmed into animals. In the heartless rule book of evolution, death is surely a good thing unless it happens before you manage to reproduce. If living too long is such an obvious evolutionary disadvantage, could death just be a clever genetic strategy? Organisms that die off promptly after completing the duty of reproduction do a favour to their offspring. Perhaps natural selection has naturally selected genes that tend to kill off those who've outlived their usefulness. This kind of Darwinian explanation for death is almost certainly correct for some species. Take, for instance, the mayfly. Its fate is evident in the Greek name of the order of insects to which it belongs, which means short-lived winged creatures. The larval stage, lucky larva, survives in freshwater streams and rivers for a year or more. And the beautiful adults have the pleasure of flight, wings. The males have large eyes to spot females, very long front legs to grab them in midair, and both males and females have 2 sets of genitalia. The good news then is aerial hanky-panky. The bad news is that they live for only a few minutes. Their genes don't even bother to endow them with a proper mouth and guts, so they starve to death as soon as the fun's over. Being unable to eat is a pretty extreme genetic adaptation. But the cells of every species tend to accumulate molecular mistakes as they grow older, and some of these occur because of specific genetic programs. Some genes, for instance, that are essential for early development produce proteins that damage older cells. And the repair of DNA, which is essential to prevent cancer, gets less efficient over time. The unfortunate mayfly is an extreme example. In most species, there might simply have been no pressure to select genes that specifically protect older cells after the age at which their owner is capable of passing on their genes. More remarkable is the fact that some species seem not to age at all, or hardly at all. The famous bristlecone pines of California, for instance, certain jellyfish and sea anemones and fish and lobsters grow continuously by replacing cells, replacing perhaps all of their cells. They survive a very long periods. They do die eventually, but only because something kills them, or infects them, or serves them up with hollandaise sauce. Whatever the genetic mechanism for regulating cell protection, the fact that life expectancy varies so much from animal to animal is, of course, a great encouragement to Aubrey and others who are keen to prolong human life. Much of the effort to find a modern-day elixir of life is aimed at promoting stem cell repair or propping up creaking mitochondria in an attempt to replace or repair tired cells. Aubrey does understand that the problem of simply fixing all the problems that lead to human disease is not trivial. But he has boundless confidence in the pace of biomedical research and the omnipotence of researchers. That's very flattering of you, Aubrey, but there's an important dividing line between confidence and delusion. Aubrey describes the 7 deadly sins of aging, the 7 changes that increase susceptibility to the diseases of old age, changes inside cells, between cells, outside cells, changes in chromosomes, mitochondria, and so on. But these simple slogans gloss over the extraordinary complexity and variety of disease, all with different causes, different patterns of pathology. Each one of those 7 categories consists of a breathtaking variety of potential physical and chemical errors. Take one of the most important of the deadly sins, changes in chromosomes. Now that sounds like a simple problem to tackle. Aubrey knows about the 23 pairs of chromosomes in human cells. He knows about the 3 billion base pairs that encode information in our DNA. Errors in individual bases can, of course, directly cause disease. Take, for example, the terrible neurodegenerative condition Huntington's disease, which I know a little about because my own research group has worked on it for about 10 years. You'd think that Huntington's disease would be really easy to understand and to fix. It's a simple autosomal dominant inherited disorder. If you've got the mutation, you'll get the disease. The gene was identified in 1993, the first gene cloned for a human neurological condition. We know the nature of the protein which is produced by the gene. We know which specific nerve cells are affected in the brain and eventually die. A genetically engineered mouse has been created which carries the human gene for Huntington's disease, and that's been enormously valuable in promoting research. Yet, despite the apparent simplicity of this disease, we still don't really understand what actually goes wrong, why particular nerve cells are affected. We don't understand why the symptoms usually appear in sort of early middle age, even though the mutant gene was present throughout life. Most depressing of all, despite the vast amount of research on Huntington's disease, it hasn't given us any clear idea how to develop a drug to treat it or a strategy to prevent it. And even if we had such a drug tomorrow, the clinical trials that would be needed before the new treatment could be approved and distributed would take another probably 10 years. Remember Aubrey's prediction that within 25 to 30 years from now, we'll have a 50-50 chance of completely stopping people from dying of old age. But it's nearly 20 years since the gene for Huntington's was identified. That's the simplest brain disease to understand, and we're still at least 10 years away from having a treatment. Now think of the myriad other diseases of the nervous system that aren't simply genetic disorders, much more complicated and unclear in their molecular basis. Schizophrenia, migraine, Parkinson's disease, motor neuron disease, multiple sclerosis, Alzheimer's, stroke, epilepsy, brain tumors, depression, macular degeneration, deafness. Age is a risk factor for many of those brain disorders, as well as, of course, for a vast range of other clinical conditions, cancers, heart disease, arthritis, diabetes, and so on. There's not going to be a quick fix for brain diseases, Aubrey, but a little more of this later. Cell replacement, as you've heard, plays a big role in Aubrey's list of engineered repairs, and I know a little bit about that. I was chairman of the International Stem Cell Forum. What I know is that there is great hope for the gradual development of stem cell therapies. But there's also the realization that the technical problems are huge, timescale very long, and unfortunately, rampant cell replacement of the sort that works apparently well enough in bristlecone pines carries its own risk, the risk that it might get over rampant and cause cancer. Now, some, perhaps, as he said, not Aubrey himself, see an attractive alternative to the patch and repair approach to life extension. They want to go straight for the elixir, a single magic bullet to extend human life. And one of the most interesting approaches to this quest is the discovery that basically starving animals can actually make them live longer. In the 1930s, scientists discovered that rats live longer if they're fed on a low-calorie diet, so do mice, fish, dogs, flies, worms, and even yeast. A recent publication on the effect of calorie restriction in monkeys, although superficially positive, has been very heavily criticized, greeted rather skeptically. Nevertheless, that general area of work has stimulated a great interest in the possibility of developing some quick fix which would go to the heart of the mechanism of calorie restriction. There's some evidence that the effect involves activation of a family of 7 enzymes called sirtuins. Resveratrol, which is a substance found in grape skins, unfortunately at very low levels in wine itself, seems to activate one of those sirtuins, and there are claims that that substance, resveratrol, extends life expectancy in at least yeast, worms and fruit flies, but probably not in mice. An alternative theory says that calorie restriction inhibits another molecular pathway that regulates energy utilization. And a substance called rapamycin, a bacterial product first found in soil samples from Easter Island, which inhibits that pathway, does extend life in yeast. But significantly, in mice, it decreases mortality even if given in middle age. So there's some interesting areas of research here. These modern searches for the philosopher's stone have so far been hardly more successful, though, than the multitude of efforts in the past. More than 2,000 years ago, the Chinese were eating jade and drinking gold to try to live longer. By the 6th century AD, the fashion there was for mercury, sulfur, and arsenic. Yes, arsenic. For the Scots and Irish, whiskey has always been thought to have life-preserving properties. In 18th century Europe, inhaling the sweet breath of virgins was supposed to be very good for elderly men. In 1889, the eminent physiologist Edouard Brown-Séquard announced that he'd devised a rejuvenating therapy by injecting himself with a liquid derived from the testicles of dogs and guinea pigs. And in the 1990s, Virginia Medical School professor William Redelson touted melatonin. Only 18 months ago, Dr. Nisoli from the University of Milan announced that drinking water containing a battery of amino acids extended the lifespan of mice by 12%. There's a lot of this going on. And at first blush, this burgeoning field of research seems both noble and profound. But success in achieving the goal of immortality would be a disaster of apocalyptic proportions. The first and most obvious problem is that many things go wrong in old cells. Clearly, there is no single aging process that increases the risk of all age-related disease. If that were the case, the patterns of disease in individuals would be much more similar than it is. So one huge worry is that the discovery of a treatment that arrests one aspect of cellular aging might reduce the incidence of one group of diseases and therefore extend average life expectancy. But if it didn't also miraculously fix all the other problems of old cells, it would simply lead to people living longer but getting the other diseases of aging. The hydra-headed problem of life extension, chop one head off and another one grows, is actually already with us. Let me explain. Life expectancy in the developed world has been increasing by an average of 7 hours a day. Think about that, 7 hours a day increase in average life expectancy since 1840 when records began. This is the simplest indicator of the success of modern medicine. Each major development in prevention and treatment decreasing a little the average chance of dying. What's really remarkable is the inexorable linearity of this increase, despite the fact that clearly different stages in that progress have been driven by different sorts of intervention. Benefiting very different groups of human beings. Clean water and sanitation, better food in the 19th century, better care for pregnant and birthing mothers and their babies in the early 20th, introduction of vaccines and antibiotics in the 1940s, better treatments for cardiovascular disease, improvements in survival rates for cancer in the late 20th century.
And less smoking.
And less smoking. We'll come to that. Of course, the gradual increase in average lifespan is generally welcomed, but more important is the better prevention and treatment of particular sorts of disease that's driven this change. But the downside is there's been little or no change in the pattern of incidence of other age-related diseases that can't yet be adequately treated. The chance of getting Alzheimer's doubles every 5 years from the age of 65. More than 40% of people are over the age of 84 in the United States are said to have Alzheimer's. The World Alzheimer Report 2011 estimated that 36 million people currently suffer from dementia, mainly caused by Alzheimer's. It's projected to quadruple by 2050. The economic cost of dementia alone, calculated at more than $600 billion, about 1% of the entire world GDP. So the problem is that almost no neurological or mental health problem can yet be really effectively treated, let alone prevented. Indeed, we don't even understand the causes of most of the major nervous system disorders. As I already said, age is a serious risk factor for many of the most debilitating and costly of these diseases, including stroke and depression and all of the neurodegenerative diseases. The horrifying increase that we're already experiencing in the prevalence of brain disorders is the downside of the increase in life expectancy that we've already enjoyed. It is a dilemma. I mean, I respond to some of Aubrey's challenge about what we should do in the face of it, but we have to recognize the problem. Aubrey, I suppose, would simply say, well, give me the money and we'll solve all of these problems in 20 to 25 years. I'm afraid that vastly underestimates how long it takes to develop safe new treatments, even when the causes of disease are completely understood. Remember, for example, perhaps the most significant recent development in new drug treatments, the development of monoclonal antibodies. We know a lot about that because it was largely achieved in the MRC Laboratory of Molecular Biology in Cambridge. The story started in the 1950s with Cesar Milstein's interest in the diversity of antibodies and his desire to produce large quantities of pure antibodies. And as you'll know that am I over time?
Slightly.
Am I really? All right. Let me come to the punchline. You can sit down, by the way. The point there is it took something like 35 years of work in perhaps the best biological laboratory in the world to develop the first drug for treating one disease. It's a long business. Okay. Aubrey has his supporters, of course. The American futurologist and fan of transhumanism, Ray Kurzweil, writing in the high-impact journal The Sun, said, I and many other scientists now believe that around 20 years we'll have the means to reprogram our body's Stone Age software so we can halt and then reverse aging. Then nanotechnology will let us live forever. Nanotechnology will extend our mental capacities to such an extent we'll be able to write books within minutes. Virtual sex will become commonplace. I expect it was The Sun that asked for that line. So with friends like that, Aubrey, maybe you don't need enemies, but I'm afraid you have got some. The biogerontology community is divided on the idea of engineered treatment of senescence, but one has to say that still a very large fraction of the leaders of it are strongly opposed. Jay Olshansky, for instance, said to get to the figure of 5,000 years, you'd only have some people living to 10,000 or 15,000 years. The only place that's going to happen is in Aubrey's work. And in a BBC News website article responding to Aubrey's article, he said that Kurzweil and Aubrey are tantalizing us with the tale that we all so desperately want to hear and have wanted to hear for thousands of years. Live life without frailty and debility and dependence and be forever young. The seduction will no doubt last longer than its proponents. In 2005, 26 leading experts in aging research from North America and Europe published a paper in the EMBO journal entitled Science, Fact, and Sense's Agenda. And they considered critically Aubrey's ideas about engineered negligible senescence and wrote, in the word of the great American journalist H.L. Mencken, for every complex problem is a simple solution and it's wrong. Each one of the specific proposals that comprise the Sense Agenda is, at our present stage of ignorance, exceptionally optimistic. Therefore, by multiplying the probabilities of success, the claim that all of these proposals can be accomplished, although presented with confidence in de Grey's writing, seems nonsensical, and so on. The American biogerontologist Richard Miller was at least humorous in his criticism. This is a message from him to Aubrey. Dear Aubrey, I saw you on TV the other day and was hoping that now that the aging problem's been solved, you might have time to help me in my publicity campaign to solve a similar engineering challenge, one that's been too long ignored by the ultra-conservative, fraidy cat mainstream scientific community, the problem of producing flying pigs. We mustn't be afraid to debate with Aubrey and to give him a hearing. After all, disagreement plays a large part in the progress of science. Even maverick ideas can sometimes be correct in driving paradigms of change in science. But it's essential that discussion and the consideration of alternative views is based on solid evidence and realistic analysis, and not contaminated by hype and trial by media. So I've argued that the complete elimination of aging would be dangerous. Fortunately, it's it's impracticable. And I would urge you to set aside what is doubtless your opinion of Aubrey and his eloquence. As a bloke, he's a nice guy, he's likeable, clever, sincere, and well-intentioned, but that's not what we're debating tonight. The issue is whether it's realistic, worthwhile, and morally defensible to try to eliminate ageing completely, and I urge you to vote against the motion.